So welcome to Maths and Science Unpacked. In this video titled Algebra Expansion 2, we want to look at more difficult forms of expansion. Okay, in the earlier video we used very simple examples. For instance, you could be given 2 3s minus 5 to expand this. Very simple. We typically used examples where there was only one term sitting outside the bracket and then you are to expand this. Of course, this is very easy. At this point in your lesson, you know that this will be expanded to be 6s minus 10. Okay, simple as that. But what happens when we have something much more? So, for instance, I have s plus 3 and then I have another term s plus 4. This type of expansion, I said in my previous video, will result in what we call a quadratic expression. This expansion will give us something called a quadratic expression. How do we know that? It's simple. The expression has a common variable. Each of the binomials have a common variable, and in that case we are going to end up with a quadratic expression. And in maths, quadratic expression simply means an algebraic expression where a variable has a highest power of 2. So we scan through the expression, we look at all the variables, and any variable with a power of 2 makes it a quadratic expression. So quadratic expression can be as simple as y squared or 3s squared or 2s minus 4, 2s squared minus 4. All these are quadratic expressions, strictly speaking. But there is also a general form of quadratic expression. I explained it in my previous video, so you can check the video title Algebra, Further Terminologies, Binomial and Quadratic Expressions. You can check that video out and see the explanation. But in this video, we want to see how we go through some more difficult forms of expansion, such as the one on the board, which is actually called quadratic expansion. So let's look at an example of quadratic expansion. I give you s plus 3, a binomial, another binomial, s plus 4, and you are to expand this. It's very simple. I'm going to color code everything so that it will be easy. So we have the green team and the red team. Okay. When we are expanding binomials in this form, or you can even stretch it and have even 3 or 4 binomials at the same time that you are attempting to expand. What happens is that we use a distributive approach to make sure that everything is taken care of. So this green guy will go for every single term in the other expression, and then this red guy will also go for every term in that. So a kind of distributing, we are distributing the terms in the first expression, each of them, over each of the terms in the second expression. So the green bit will result in s squared plus s 4s. The red bit will result in plus 3s plus 12. Okay, so we are multiplying out every one in the first bracket to the second one. And then now that we have this, remember our skill of simplification. These are like terms. Okay, they all have a variable, common variable, like terms. So we can simplify that and make the whole expression more concise. So that gives us s squared plus 7s plus 12. Okay, so that becomes a quadratic expression resulting from the expansion of two binomials. Okay, so that is it. Let's look at another example. T plus 5 expanding over t minus 2. Okay, same thing. Each of the terms in the first bracket goes for each of the terms in the second bracket. So typically we are going to have 4 terms and then we simplify. So the first one, this goes for that, t squared. This goes for that, minus 2t. This goes for that, plus 5t. This goes for that, minus 10. So now we have like terms. This and this are like terms. So we can simplify further and make our expression more concise. So we are going to get t squared plus 3t. Negative 2 and 5 gives us positive 3 and then minus 10. So that is what we can get. And of course, this one that we have here is a quadratic expression because we had a common variable in both binomials. Okay, and when we expand binomials where there is a common variable in each of them, we end up getting a quadratic expression. So that is it. There are many examples that you can try out on your own. So for instance, you try this one on your own and drop your comments, your answer in the comments. S plus 3, S plus 5. How can you expand this and what do you get? Do it on your own. Whatever you get, you are free to drop your answer in the comments and we can discuss that further. Now it gets even more difficult. We will not always be stuck at multiplying out just two binomials. What if we are asked to expand a binomial but squared? Okay, so first we've looked at expanding two binomials in the form 2s plus 3, 4 minus 3s. We have looked at this. What if I just give you 2s plus 3 squared? Okay, that is also a more challenging expansion question that you could be given. Okay, we call it expanding squares. Expanding squares. Now let me tell you something interesting about math. I know some of you have already taken some lessons in, for instance, indices. Okay, powers and indices. And so you are familiar with a power sitting outside a bracket of an expression. Okay, there is a temptation for you to apply this power to that and apply this power to that. But that is not what you have to do for things like this. you only apply power to each of the components of a term if it is not an expression but a term. What I mean is, let's say you have 3sy in a bracket. It's just an expression, although it seems to have a lot of components with a square sitting outside. That one, you can apply the square to each of them by way of simplification. So here, for instance, you are going to get 9s squared y squared. It's all right to do it if it is a single term sitting in a bracket with a power outside. But if it is an expression with different terms, as you can see, we have 2s and we have plus 3. If it is an expression with different terms and they are in a bracket with a square sitting outside, you can't use that. You will have to go back and look at what a square means. So let's go back and look at what a square means. First of all, if I have a squared, it is a times a, isn't it? Strictly speaking, if I have 3 squared, it's actually 3 and 3 multiplying itself. Okay, therefore, if I have an expression 2s plus 3 squared, don't be tempted to go down this route, 4s squared plus 9. Don't be tempted to go down this route. You will not be correct. You will not be correct. We can leave it here and do the correct thing and compare it to it. Let's do the correct thing in the green. 2s plus 3 squared. This one, I have to follow the same pattern. When it's a squared, is a in bracket and another a in bracket. When it's 3 squared, it's 3 in bracket, another 3. So multiplying 3 by 3. When it's 2s plus 3 squared, it should be the same thing that I did for this. It should be 2s plus 3, another 2s plus 3. And then I proceed like we did in the first part of this video, where we use the distributive approach to make sure that every single term in each of the brackets go for every single term in the other brackets. Okay, so here I'm going to get 4s squared for this and this, plus 6s for this and this, plus 6s squared for this and this, not 6s squared, sorry, 6s for this and that, and then plus 9. Okay, now let's simplify because we can actually see some like terms. These are like terms, so let's simplify. Simplifying will bring us to 4s squared plus 12s plus 9. Now, guys, look at something for me. Look at something for me. When we were going through one route that we think is a possible solution, we ended up with 4s squared plus 9, assuming we were just applying the square to each of the terms as simple as that. We ended up here. But when we did it correctly in the more acceptable way, we ended up getting that. So you can see that this is significantly different from that. They look similar. Okay, this portion is there, that portion is there, but we are missing this bit, and this bit is significant part of it. So whenever we are expanding squares, you have an expression all squared. Just treat it like you have a simple number squared. It is that expression multiplying itself again with the same expression. And that is what you have to do in order to expand squares correctly. Okay, let's look at one more example and then we can draw the curtain on this example. So we have 3s minus 2 squared. So now we know the correct way of proceeding with such expansion. We need to treat it as 3s minus 2 multiplying itself twice. So if that is the case, then 3s minus 2, another 3s minus 2. Then we use the same distributive approach to distribute all the terms in the first bracket over all the terms in the second bracket. So we are going to get 9s squared minus 6s minus 6s plus 4. Remember, negative times negative is positive. So 9s squared minus 12s plus 4. That becomes the solution we are looking for. That becomes the solution we are looking for. So we now know how to expand brackets correctly. The last bit that I want us to quickly go through is when we have more than 2 brackets, when we have more than 2 binomials, it becomes a bit interesting. So what do I mean? S minus 3, 2s plus 4, s minus 1. Okay, now we don't just have 2 binomials expanding, we have 3. And what do? It's very simple. If you can do expansion over 2 brackets, you should be able to use the same skill to expand over 3 brackets. What do? All what you need to do is to decide to break them. Okay, so here you can decide to break it into 2 parts. 2 brackets going to 1 part, and then the third bracket staying another part. Forget about the third bracket for now. Focus on the 2 brackets. Solve the 2 brackets the same way that you are going to solve expansion over 2 brackets, like we've done severally in this video. And then whatever you get, now come and expand the third bracket over that. So watch me. I'm going to expand this one. So 6s squared minus 6s plus 4s minus 12. So let me first simplify. I'm going to get 6s squared minus 2s minus 12. Now, I have simplified that. So in place of this, I now have this. In place of this, I now have that. So now that I've simplified all this into just one expression, I can put that in a bracket and then bring this one that I left behind to expand over it, s minus 1. As simple as that. we are going to stick to the same distributive property. So this S will go for everything here, and then this 1 minus 1 will also go for everything here. We'll get a very long expression, but we will simplify and then we will get our correct answer. So let's start first with the S. 6, sorry, let me use a more visible color. So 6, oh no, sorry, 6 S cube, we are talking about this and that, minus 2 S square, we're talking of this and that, minus 12S. Now we come to the minus 1 expanding over that. We are getting minus 6S squared plus 2S, that is this and that, negative 1 times negative 2S, and then plus this and that, giving us 12. So the same principle, we are distributing each of the term in the first bracket to over each of the terms in the second bracket, and we've got a very long thing, but we need to just identify like terms. So to make it easy, let me use color coding to identify the like terms. So we have, first of all, let me do some quick correction. This must be 6S cube. It's cube, not square. This is cube, not square. Okay, so I'm using color to identify. So first we have some like terms here. This S square and this S square are like terms. Then we have other like terms here. Minus 12S and 2S are like terms. So I'll have to put all these together to make my expression more concise. So making my expression more concise, I'm now left with 6S cube minus 2S square minus 6S square is minus 8S squared minus 12S plus 2S remains minus 10S, and then of course nothing else, so plus 12. So that becomes the final expression that we get when we expand these three brackets. Another person could have chosen to break their expression here, expand these two, and then whatever they get, they expand over that. It will be the same thing. So long as you are following the principles and doing everything correctly, you will get the same answer. All what is necessary is that you follow the principles, you do what is right, and then whichever part of the three binomials you break, you solve the first two, you bring it to solve over the last bracket, you will end up getting the same answer, correct answer. Thank you and have a wonderful day. See you in our next lesson.